Hi everyone. All right, we're going to do operations with vectors. So we're going to start off by talking about adding and subtracting of vectors. So the two that we're going to use are the u and v right here. So u equals 3, 4, v equals negative 1, 5, and we're going to add them together and then we're going to subtract them together. So I have over here that order does matter. Okay, so make sure that whenever it's written, you're writing your operations the same way. So what I mean is that if it's u plus v, you're doing u plus the value of v, and then u plus the value of v. So now when you do this, you take your changes in x's and you put them together. And then the same thing with your y's, you're going to take your y's and you're going to add them together. All right, so then our resulting vector for the addition problem is 2, 9. So then same idea for u minus v. We have u minus v, our change in x's, and we have u minus v, our change in y's. So we should have a positive 4 and negative 1. Order does matter here because if you just decided that you were going to write it correctly for the first one for your changes in x's, but then you switch the order here, which I know sometimes we can do, this does give you a positive 1 now, which changes the direction and starting and end point of what you're looking at. So make sure that you're putting the order in the right way. So that's addition and subtraction. We're going to jump down to multiplying by a scalar. If you remember multiplying by a scalar, it's just multiplying by a number. And that's all a scalar is. So we're going to do 4u, and then we're going to do a combination of the two that we just talked about. So we're going to use the same vectors. We're going to use 3, 4, and negative 1, 5. So if we're multiplying u by 4, we're just going to take the value of the x's, multiply by 4, and then we're going to take the value of the y's and multiply by 4. So then we should get a vector of 12, 16. So now we're going to use the two that we've talked about, and we're going to put it all together. So I'm going to do it in pieces. So the first thing I'm going to do is I'm going to find 3 times u. So this is then 3 times 3 for our x's, and then 3 times 4 for our y's, which gives me 9 and 12. Then I'm going to go ahead, I'm going to find 4 times v, which is 4 times negative 1, 4 times 5, and then I should get for 4v, it should be negative 4, positive 20. And then if I go ahead and do the actual addition together, I'm going to go ahead and do it up top. I'm going to take my 9 plus negative 4, and I'm going to take my 12 plus my 20. So then I should get 532 for the whole thing. That's my answer. All right, so that is operations with vectors. There are other vector properties, but they're all pretty straightforward from what you've learned before, so we're not going to take the time to talk about them. We're going to just go ahead and jump down to something called I and j. So vectors using I and j. So vector I is 1, 0, and vector j is 0, 1, and these are called unit vectors. These are called unit vectors. So what that looks like on a graph is right here to the right. You would go over 1 unit for I, and that would be the vector for I. You would go up 1 unit for j. It's called unit vectors because it moves over a unit. So then there's something called doing vectors in terms of I and j. And it's just a fancy way of using your vector operations and kind of substituting at the same time. So what I mean is we're going to go ahead and take our vectors u and v. So u is negative 2, 4, and v is 3, negative 1. I switched them up for this particular problem. So what we're going to do is we're going to put these in terms of vector I and vector J. So what that's going to look like is just this. If I take vector U and I put it in terms of I and J, all that means is I'm going to take my -2 and I'm going to multiply it by my unit vector I, and I'm going to add that to, my 4 times my vector J. And that's exactly what we're going to do. So I will go, this goes with your change in x's, and your J goes with your change in your y's, and then you're going to add them together. So I'm going to do the same thing with V. I'm going to put V in terms of I and J, which means I'm going to take my change in x's, which is 3, multiply it by my I, then I'm going to take my change in y's and multiply it by J. So this one I can actually rewrite as just subtraction without the 1. You can leave the 1 in there if you want. Either one I think is perfectly fine. This one is obviously more simplified, but that's all you're doing for your unit vector. So we're going to do one last example, kind of culminating everything that we've done. We're going to take 3u plus 2v, and we're going to put it in terms of I and j. So using the same vectors u and v, the same in terms of that we did in this step, and we're just going to set it up as an addition problem with scalars. So I've already put my vector u in terms of I and j right here. So I'm going to take my 3, which is my scalar, and I'm going to multiply that by the problem, the addition problem above with the I and j, because we've already done that. We've already converted it to I and j. Then I'm going to do the same thing with v. I'm going to put my scalar, and I'm going to take what I got for vector v in terms of I and j and rewrite it in there. So now I can just focus on doing algebra and solving my problem. So now I should have -6i plus 12j plus 6i minus 2j. We've got some canceling we can do, and we've got some combining terms we can do. All right, and that's it. That's all you're doing. So it's just a very basic way of substituting using vectors. So if you want to look at it as you're using operations to do substitution, I think that's the easiest way to think about it. That's really what this comes down to. But that's 7.2. So I'm going to put this in the Edpuzzle. Obviously, you're doing the Edpuzzle right now, so that was really dumb for me to say. But after you do this Edpuzzle, I am going to find some 7.2 practice, and then I'll put a 7.2 key out there for you. All right, and if you have any questions, come see me during office hours. Have a great day.